Hello, good day everyone. So you're welcome back to our YouTube channel. It is Isa Confidence from High Achievers Academy, and today we're going to be talking about data structure in algorithm. And we are going to be looking at the sort and search algorithms of the binary search, bubble sort, and so on. We're also going to be talking about arrays and stack data structure. So we are going to learn how to find data like a pro and search through arrays. So if you are yet to subscribe to our channel, please ensure to do that now. Now, let's talk about the binary search algorithm. Let's talk about the binary search algorithm. So let's say you're in a church service and a preacher asks you to locate a Bible verse. So let's say something like we use the Bible book of Romans. Now, if a child is to find this portion, most children are going to um, they're going to they're going to start finding this portion from the Old Testament down to the New Testament. They're going to start flipping right, looking for Romans. But I think every adult is going to divide the Bible into two, locate the New Testament and locate Romans. Why? Because we know that Romans is in the New Testament. Therefore, we don't have business with the Old Testament. So the binary search algorithm is an algorithm that helps us to find our data in an array very fast. We don't need to go through the whole elements in our array. So, for example, if I have 1000 data sets in my array, I'm looking for the 999th element in that data set in the array. It's not going to be a good decision for me to actually start looping through from the first element down to I get to the 999th element. That's time wasting. So with the binary search algorithm, we have a more faster method in searching for the elements which are in an array. So let's say I have this array. This is an array of 1 to 10, but it's unordered. So to actually use the binary search algorithm, we need our data to be ordered. For example, if I'm to find the number 7 in this array, I need to sort the data, arrange it in ascending order. So here I have 1 to 10 arranged in ascending order, and this is my element 7. So what do? I can divide this array into two halves. Then we know that 7 is on the right side. So I'm going to look through the right rather than looking at elements which are on the left. So that is how the binary search algorithm works. Now, let us dive down into how we find the middle point. So how do we find the middle point? The middle index is equal to the floor of low plus high divided by 2. Now, what is this low? So this low is equals to 0 and high is equals to n minus 1. Remember that n is the size of our array. So I have 10 elements here, n is equals to 10. So for this array which I have here, high is equals to 9 and low is equals to 0. Now, I have that the mid is going to be the floor of low plus high divided by 2. What is the floor? The floor of a value takes the least positive integer. So if I have the floor of 4.5, the floor of 4.5 is 4. So you need to take note of this. Now let's dive down into the code implementation. So for this code implementation, I'm going to be using C language. I'm going to be using C programming language. So if you're not used to the language, I'm going to be explaining and breaking down the language so you can understand how the program works. Also, I'm going to be having an iteration test to help you see how this binary search algorithm works in a real life array. So let's dive down into the code implementation. Now we have hashtag hash include stdio.h. What does this mean? This is telling you to import the library for input output function. So example of input output function, we have the printf, we have the scanf. Now After this, what do we say? We are going to call in a function known as binary search, which is taking up an array called R, and we have int size, that is, we declare the size of the array, and also in this function we pass in the parameter of what we call target. Target is the value which we are looking for. Target is the value which we are looking for. Now our goal is that we are going to find the index of where our target lies. So that is the goal of this program, is to find the index where target lies. Now after doing that, I'm going to initialize low to be 0 and high to be equal to size minus 1. I showed you why we are doing that. Now after initializing low to be 0 and high to be size minus 1, remember that low is the starting index while high is the size minus 1. Now we're going to call in a while loop, and we're going to say while low is less than or equal to high. So what are we doing here? This is like a magic trick. We are to find the middle spot. So if low is 0 and let's say high is 9, this condition is actually true. So what is going to happen? We are going to move down to finding the mid of that array, which we are going to pass into this function of binary search. So this is the formula of getting the mid, and whatsoever we get as the mid, we pass it into this if statement. So we say if array of mid is equals to target, what do? We return mid. So if mid is, let's say, an array of 10 elements, the mid is going to be the floor of 4.5, which is going to be 4. So if array of 4, which is going to be the fifth element, is equals to our target, then what do? We return that index. So that being said, we have a printf statement which is going to print that we found our target. But else, if that is not working, what do? We call in another if statement which is similar to what we have here, and we'll say if array of the mid is less than target. So what if we have that this is not 0 and this is not, and target, say target is not, let's imagine our target to be 7. An array of mid was 4. So if 4 is less than 7, is that condition true? That condition is true. What should do happen? Low should be equals to mid plus 1. So when we say low should be equals to mid plus 1, what are we saying? We're telling this program that it should move to, that targets cannot be on the left hand side, so targets should be on the right hand side. That's what this line of code means. The target should be on the right hand side. So we are going to forget everything which is on the left hand side and focus on the right hand side. Now, but what if this condition is not true? What do we say? We say else high should be equals to mid plus 1. That is, if this condition is not true, if we are not focusing on the left hand side, if we're not focusing on the right hand side, then we should reduce the mid value and focus on the left hand side. Now after that, we are going to call in our this in our main function. Below our main function, then we pass in the parameters and our targets, then our this in our function, passing our parameter and our function. Now let me explain this program from the scratch, but I'm going to do that in a more refined way. So we're going to have an iteration test. The iteration test will help you see how this program is working. So I don't just want to give you the program without you understanding its implementation. So let's dive down into the iteration test. Now for the iteration test, we have the first iteration. We say that while low is less than or equal to high, while low, so in this case, what is low? Low is 0 and high is what? High is 9. So while 0 is less than 9, this condition is said to be true. This condition is said to be true. So what is going to happen? We are going to say that we're going to read this line of code. We say if array mid is equals to target. Now what is mid? Let's calculate mid. In this case, our low is 0, our high is 9. So therefore mid will be equal to the floor of 4.5, which is 4. So therefore we can rewrite this if statement to be if array of index 4 is equals to target. What is the array of index of 4? These are my index here. That element is 5. Now let's say our target is 7. Let's use 7 for our targets. Let's use 7 for our targets. Now, is 4 equals to 7? This condition is not true. 4 is not equals to 7. So what happened? 4 is not equals to 7. Then we come down to this part of the program. Now, is 4 less than target? 4 array of mid is 4. Remember, array of mid is 4. Is this less than target? Target is 7. And array of 4 is 5. Array of index 4, the value is actually 5. Is 5 less than 7? That is correct. So what is going to happen? Low is going to be equals to mid plus 1. Remember that mid is 4. So low will be equals to 4 plus 1, which is 5. Now, so that being said, what do? We have that low is equals to 5 now. Now we are going to start back inside the top of this while loop, and we're going to calculate mid again. So we're going to come back and say, while 5 is less than or equals to 9, is this condition true? Yes, the condition is true. So what should we say? We should say that int mid is equal to the floor of low plus high divided by 2. And that is going to give us, what is going to be mid? Mid is going to be 7 now. Mid is going to be 7. So what do we do? Now we are going to test this conditional statement, which is here. So we're going to say if array of mid, now that is array of 7, is equal to targets. Now this is array of index 7, and that value is 8. What is target? Target is 7. Are these equal? They are not equal. So what is going to happen in this case? Now that is where this else high is equals to mid minus 1 is going to come. So I'm looking here. I have passed my targets. My target is 7, but with this operation, that's the second iteration, is taking me to a number which is higher than where I want to be. So what do? We need to come back. So that is, we're now going to say that high is equals to mid minus 1. Now remember that mid is 7. So high will be equals to 7 minus 1, which is going to be 6. High is equals to 7 minus 1, which is going to be 6. Now after doing that, we're going to say while 5 is less than or equal to 8. While 5 is less than or equal to 8, what should happen? This condition is said to be true. So we're going to say int mid is equals to the floor of 5 plus 8 divided by 2. And that is going to be 6. So the array of mid, remember that mid is now 6. An array of 6, what is array of 6? Array of 6 is 7. So we have come back before we went ahead of the value which we're looking for. And this high is equals to mid minus 1 helped us to return back to where we want to be. So now we're going to say if array of 6 is equals to target is 7, an array of 6 is equals to 7, then what do? We return mid. That's why we're returning that 6 is the index which we found. So in the next video, I'm going to be discussing, in the next video, we're going to move further to discuss about the bubble sort algorithm. So do also subscribe to the channel. See you in the next video.